Okay, so yep, it's now time for leg day. One of my all-time favorite SpongeBob memes for something like this. But we're going to move on to a third type of equation in this section, and this equation will involve quadratic expressions. All right, so a quadratic equation is an equation with a quadratic expression in it. Again, Captain Obvious sort of statement there. And there are many ways that a quadratic equation can start out. The most common uh, format for a quadratic equation, or I should say at least the most desired format, is one in which the quadratic expression is in standard form. So with two of these three methods that we'll use for solving these, we're going to want the quadratic equation to be written in this format: ax squared plus bx plus c equals 0. And the reason why this would be considered a quadratic equation versus anything else is because the highest power on x is 2. Okay? Now, there is a condition that the coefficient of x squared does not equal 0. And the reason for that is because if a were 0, the x squared would go away, and we'd have a different equation. But that we can allow b and c to be 0. So sometimes you might be missing the middle term, sometimes you might be missing the constant. But regardless, if your highest power of x in the equation is 2, and there are no variables in the denominator, we have a quadratic equation. And this quadratic equation is said to be in standard form. Now there are really 4 by hand methods that we can use for solving quadratic equations. Those would be factoring, something called the square root method, completing the square, which we're not going to do in the notes in this session, but instead I'm going to have some videos to just show you what that's all about. And the reason for that is because you don't necessarily have to complete the square with any of these quadratic equations, because there is something that will solve all quadratic equations, and that's the quadratic formula. And most people tend to elect doing the quadratic formula versus completing the square. All right, so we won't be doing this in class, but I will upload videos just so that you have an idea of what that technique is. So what I have for us is a table that I made which will help differentiate a number of things. Number one, the format of the equation that you'll want to have it in before you apply the technique, and also just some starting steps for how you solve from there on out. And then I'll include some examples, which I have written down here. I didn't get a chance to type them in. So if you're going to apply a factoring method, which it's in the name, all right, there will be some factoring at some point. You want the quadratic equation to be in standard form. So it needs to be written as ax squared plus bx plus c equals 0. And the method, like I said, it's all in the name. It involves factoring. So if you're able to factor this left-hand side, let me write those generically as maybe capital AX plus capital B times capital CX plus capital D equals 0. If you're able to factor, then when the right-hand side is 0 and the left-hand side is factored, you can set each factor equal to 0. So we could set AX plus B equal to 0. We usually include the word or, and then we can set CX plus D equal to 0. And then we solve these two equations, which are generally two linear equations. So I'll just put a little dot, dot, dot. Like I said, this is really just like the starting steps, which most people tend to struggle with, right? How do we start a problem out? So that's why I want to include that. But this process by which we set each factor equal to 0 is known as the zero product property. I call it ZPP for short, zero product property. The square root method requires a different format of the equation, and the format that you want your equation in before you start applying the square root method is in this format. Let's write quantity capital AX plus capital B squared on that entire expression equaling capital C. And it's called the square root method because we use a square root to get rid of this power of 2. And once you do that, you're left with AX plus B on the left. And on the right-hand side, we use what's called a plus or minus symbol, which would actually generate two values on the right-hand side, namely the positive version of the square root of C and the negative version of the square root of C. Okay, so just remember with the square root method, when you go to take the square root of the right-hand side, which gets rid of that 2, that power of 2, include the plus or minus. And this generates two equations. One equation will be AX plus B equals the positive square root of C, or the other equation will be AX plus B equals the negative version of the square root of C. And those are also two linear equations, and so you would solve those from there. With the quadratic formula, you want your format of the equation to be standard form again. So AX squared plus BX plus C equals 0. And it does mention the word formula, and so you're going to probably expect a formula, and I'll definitely give that to you. The quadratic formula, provided that your equation is in standard format like this, will go as follows. It's x equals, we take the opposite of b, so negative b, we write plus or minus. Let's draw a very big square root symbol there, because inside this square root goes the following expression, b squared minus 4ac. And then there's the long fraction bar with everything that we just wrote out in the numerator. Okay, most people forget, well, not most people, but a lot of people forget that this fraction bar goes underneath the negative b. Okay, so just make sure that that fraction bar goes underneath everything that we just wrote out. And there is an expression that we'll put in the denominator that's going to be 2a. So anybody seen this formula before? Maybe learned it with a song or anything like that? The tune to Pop Goes the Weasel or whatever. I actually found for the first time ever a death metal version of the quadratic formula. If anybody's interested in hearing it, just email me. It is hilarious. But anyway, you plug in all your values from the equation on the left, namely all the coefficients and the constant, and you simplify from there. And once you've fully simplified the right-hand side, you get your two answers for x. In some cases, there just might be one duplicate answer for x. In other cases, there might be no answer for x, at least for now. And then in a lot of cases, you'll get your two answers for x. So that's kind of the overarching process for each of these techniques. Let's get to some examples. So for the factoring, I'd like us to solve 3x squared plus 5x plus 2 equals 0. So remember, with factoring, you want to factor the left-hand side. Notice that the coefficient of x squared is 3. So if you're going to try and factor this, you might want to use the AC method. Okay, so we do 3 times 2, that gives us 6, which I'll do a factor table over to the left. And factors of 6 are 1 and 6, 2 and 3. And we need factors of 6 that add up to 5. And that's going to be 2 and 3, right? So remember, that breaks up the middle term as 2x plus 3x. Carry down the 3x squared. Carry down the 2. Don't forget to write equals 0. And then what we do is we factor by grouping. Okay, we can take an x out from the first set of parentheses, leaving behind 3x plus 2. And we have 3x plus 2 already inside the second set of parentheses. So in that case, just factor out a positive 1. And remember, with factor by grouping, we're hoping that the remaining expression after the GCFs are pulled out match. In this case, they do. So I'll just write one copy of 3x plus 2 and one copy of x plus 1 equals 0. So if you look at the format of the equation, it's the same format that we have right here. And what the method tells us is that once you're at this point where it's factored on the left and 0 on the right, you can set each factor equal to 0 to solve for x. So we'll do just that. We'll set 3x plus 2 equal to 0, write the word or, and then x plus 1 equals 0. And I'll have you guys solve these two right now. All right, so go ahead and take a moment to solve each of these equations, and we'll move on. All right, ready? Subtract 2 from each side. 3x equals negative 2, x equals negative 2/3. Confirmation on negative 2/3 for one of our values. All right, next one's a doozy, x equals negative 1. There we go. So we end up getting two answers for x, which is typically the case with quadratic equations, but there are some special cases where your two answers for x are duplicates, and maybe we don't get any answers for x at all, and that would be the result of trying to take the square root of a negative number. But we'll actually address that in section 1.4. But before we move on to an example with the square root method, you guys have any questions for me on this one? Okay. So the example I have in mind for the square root method is this one. Let's write 2 parentheses 5x minus 1 squared equaling 16. So keep in mind the format of the equation that we need before we apply the square root method. It's right up here. Notice that there's nothing in front of the parentheses. That's kind of a big deal. Yeah, we actually need to get rid of this 2, and we can do that by dividing each side by 2. And that gives us 5x minus 1 squared equaling 8. So we're now at this point to where we do have the proper setup. In order to get rid of this power of 2, we have to square root each side. That's going to get rid of the power of 2 on the left, leaving behind 5x minus 1. But on the right-hand side, don't forget we need the plus or minus symbol times the square root of 8. Now, before I move anything around, I do want to point out that the square root of 8 simplifies. 8 is 4 times 2, and the square root of 4 is 2, and the square root of 2 doesn't break down. So the 8 breaks down to 2 radical 2. And you want to put the 2 in front of the radical, but behind the plus or minus symbol. So because there's this plus or minus symbol, we actually get two equations here. One equation uses the positive version of 2 radical 2. Let's write the word or. The other equation uses the negative version of 2 radical 2. You guys still with me? Now, we have to solve for x still. There are a couple of steps that we need to take in each equation in order to do that. The first step, and I'm starting with this first equation, the first step would be to add the 1 over to the right-hand side. Now, pay real close attention here. When I write the 1 over to the right-hand side, I can't combine it with 2 radical 2 because the 1 doesn't have a radical 2. So the best that we can do on the right-hand side is write this as positive 1 plus 2 radical 2. We'd still have 5x on the left, in which case we'd have to divide each side by 5. And a couple ways you can do this. On the right, you can write the entire thing on top of 5. So it's 1 plus 2 radical 2 over 5. Okay, this is a legit version of the answer for x. But you can also write it as 2 fractions, as 1 over 5 plus 2 radical 2 over 5. And we would get the 2 fractions if we were to divide each term individually by 5 when we divided both sides by it. But either way is acceptable to me. But I did want to show you both ways just in case my math lab might want a particular version. Okay, I just want to tell you that both are equivalent. And with that, I'm going to have you folks solve the second equation. Okay, so go ahead and see if you can isolate x, and we'll go over the answer in just a moment. All right. So you do add the 1 over to the right again. It's going to go in the front. Let's write minus 2 radical 2 after it. 5x on the left. Divide each side by 5. And I'll give you the 2 different versions of this answer. One is when it's written as a single fraction. The other is when that single fraction is broken up into 2 separate fractions. All right, any questions? Let's move on to our last example, and then I'll give you the lowdown of what I have planned for Thursday, and also remind everybody about the chapter art quiz that's due tonight. So with the quadratic formula, let me write the example out. I'm going to write this as 3x squared equals 5x minus 1. I want you to tell me, guys, I want you guys to tell me if we need to maybe rewrite this equation before we apply the quadratic formula, or if we can just jump to the quadratic formula from here. What do you guys think? Right, you need this in standard form, so we can't jump to the formula just yet, okay? Because we need everything on the left and 0 on the right. So we can move both terms over to the left. That's going to give us 3x squared minus 5x plus 1 equals 0. And by moving things to the left, you can identify your values of a, b, and c, which are just the coefficients. Our value of a is 3. Do include the negative for your value of b, and then the value of c is positive 1. And what I do is I set up the quadratic formula with some blank parentheses. So I'm not going to write negative b. Instead, I'm going to write negative parentheses there, and you'll see why in a minute. Plus or minus the square root, parentheses squared, minus 4 times a pair of parentheses. Remember, this is all on top of a fraction bar, and on the bottom, I'll write 2 times a set of parentheses. Now, the reason why I'm using the parentheses is because typically, the quadratic formula will have you might have to plug negative numbers into the quadratic formula, and if you use parentheses to start with, it can help you avoid sign errors. So starting on the top, it should be negative b, and b is negative 5. Don't forget the plus or minus there. Negative 5 quantity squared minus 4 times 3 times 1, all over 2 times 3. And we simplify as much as possible to get our official answers for x. Now in the numerator, there's a double negative to start out with. So that's going to turn into positive 5 plus or minus. And what you want to do is simplify the inside expression. Okay, and you can actually type this expression into your calculator as it is. And don't include the square root though when you do it. But when you type this expression into your calculator and have it simplify it for you, it ends up turning into 13. But don't forget, we still have that square root from part of the formula. And then this is going to be all on top of 2 times 3, which is 6. Now in some cases, the radical simplifies. Since the radicand is 13, though, the square root of 13 won't simplify any further. And you'll notice that there are actually 2 answers for x here by virtue of the plus or minus symbol. And in some cases, you can actually leave your answer for x in this fraction format, where it's written as a single fraction. Or what you could do is break that fraction up into 2 separate fractions. So let me show you what that would look like. The first fraction will be 5 over 6. I'll use the plus part of plus or minus. And then your second fraction is going to be radical 13 over 6. That would be one answer. This is the answer where you use the plus part of plus or minus. The other answer is when you use the minus part of plus or minus. And there we have it.